Okay, we will go for source transformation theorem now. So the next question is source transformation theorem. Sorry, superposition theorem. Source transformation finished. So superposition theorem. So in superposition theorem, uh, many sources in a circuit, many sources will be there. Okay, find out this voltage across any element or current through any element. Current through any element or voltage across any element. You can find, okay, how when one source is adding, one source is active, other source should be zero. If current source, it will be open circuit, zero means. If another source is voltage source, it will be short circuit, that is zero. So find out the value, then again find the other source active and remaining sources will be inactive. Then find the value of V. Okay, these two, the first value and second value you add, you will get the final V. Understood? This is superposition theorem. So we will go for this question. Here it is. Now source 110 is active. Okay, it will be open circuit. It's simple. So when open circuit, the final circuit will be like this. And what is the value of this V? This is not V. It will be V1 or V0. You give another name. Okay. Now these two are series. Okay. By using these two are parallel. These two are parallel. You will get 35 by 6. Now 35 by 6. This is 5 as it is. You need this V1. Give the name as V1, not V. So by using voltage division also you can do. Okay, voltage division. By voltage division, directly you will get. No need of doing all these things. Huh? Total like this. Okay. Okay, I can't write here. Huh? Okay, let it be. So V1 will be 110 110 multiplied by 35 by 6. Okay, 35 by 6 divided by 35 by 6 plus 5. Like this you can do. Okay, you will get 59.231 volt. Okay, any method you can do. This is known as V1. When 4 ampere is active, this source alone is active, this is short circuit. Inactive, short circuit. Okay, so you will get like this circuit. You should be very careful here, like this circuit. So you need this voltage now, this voltage, only this voltage. So these two are parallel. Okay, these two are parallel. Since you have the same lead, this one, the value of this will be 10 by 3. Okay, 5 into 10 by 5 plus 10, 10 by 3 plus 2 plus 2 plus 2 becomes 16 by 3, 16 by 3. Any problem? Yes, tell me, any problem, you ask me. Okay, so we need V2 actually. When we find V2, we will add this V2 with this V1, you will get V. Okay, so how to find this V2? Any method you can use. 5 and 10, these two are parallel, you will get 10 by 3. Okay, like this. Then 2 is present here, then plus 2 will be 16 by 3. Any problem, guys? Okay, I did not record the superposition theorem. Okay, I have recorded this. I did not record source transformation theorem. I recorded from superposition theorem. Okay, again I will explain for after some time. Okay, now by adding these two, you will get 16 by 3. 16 by 3. 16 by 3. Now this 16 by 3 and this 12, these two are parallel. You will get 48 by 3, 13, 48 by 13, like this circuit. Then find the voltage VA, for example. VA will be IR. I is 4 ampere and R is 48 by 13. That is 192 by 13. This is VA. Then coming to again this circuit, the same circuit. What is V2? What is V2 here? The total here is VA. We need just this voltage. V2. V2 from here to here. Okay. VA is this total. You have to understand this. Is it clear? Now, coming to this circuit. This or this, both same. This total VA is from here to here. For 5 as well as 2. We need just this. What is this? 5 parallel to 10. That means 10 by 3. If you find the voltage across this, that is V2. Is it clear? So V2. V2 is total voltage VA minus VA. Why? We need here plus minus. But VA is plus minus here. So we need here plus is here minus. We need here plus minus. But what is VA? VA is plus minus. Plus minus. That's why the value is minus VA. Understood this? We need here positive, negative. But what is VA? VA is plus minus. Is it okay? Plus minus. This lead is plus, but we need here minus. That's why here minus VA. Is it clear? Multiplied by voltage divider formula. The same voltage 10 by 3 divided by 10 by 3 plus 2. Plus 2 is opposite resistance. 10 by 3 is the resistance, the voltage across which the resistance at which the voltage has to be found. Okay. Now, what is VA? VA is 192 by 3, that is minus, multiplied by 13 by 3 divided by 16 by 3. You will get minus 9.231. You add this with this, you will get 50 ohm. Okay, 50. That not written here. Clear or not? It is little bit typical. Okay, shall we go for the next question? Okay, the last question here, superposition theorem. Find I naught here. So there are three sources here, two current sources, one is voltage source. So when this only this current source is acting, this will be open circuit, this will be short circuit. That is I naught 1, I1 you can say. When this is active, this will be open circuit, this will be short circuit, this value will be I2. When this is active, this will be open, this will be open, and the value will be I3. The final I naught will be I1 plus I2 plus I3. Understood? We will go for solution. Here it is. Okay. Here. I naught you have to find. When 6 ampere alone is acting. Okay. When this alone is acting, the circuit will be like this. This 10 ampere will be open circuit. This 75 volt will be short circuit. Okay. Now, what is this? Uh, this is the total current. The current has been divided here and here. Okay. So this all are uh, parallel. 30 parallel 5 parallel 60. So 30 parallel 5 parallel 60 plus 1, it will be 5. The total will be 5. Now by using current division method, the total current is 6, opposite resistance is 20. Okay, this is opposite resistance 20 divided by 20 plus 5 total resistance, that I1 is 4.8. Is it clear? 4.8. Then the current source 10 ampere alone is acting. This will be open, this will be short. The circuit will be like this. Oh, where it is? Oh, it has not been written. If have how to type? Can I type here? Okay, when 10 ampere is active, then this will be open, this will be short. Okay, see here, the 10 ampere, the current is being divided here and here. What is this total resistance here? This total resistance is, just now we did na, we did here 4 ampere, and what is the total here? What is the total here? 20, just 20 plus 1, 21. 20 plus 1, 21. So we need this 20 plus 1, 21, this current, this current. So the value will be I cannot write, huh? here it is. I'm not will write. Okay, just I will say you write. Okay. So 10 multiplied by opposite resistance, 10 multiplied by 4, 10 multiplied by 4, okay, divided by 4 plus 21, divided by 4 plus 21. This is wrong. 40 divided by 21, 25, sorry, divided by 25, 1.6. Okay, so 40, 1.6, 1.6 multiplied by uh, 10, 16. So this I2 is 16. Then I3. What is I3? The this resistance alone is acting, and these two are zeros. These two are zeros. This alone is acting. Here 30. So you can use any formula. Where is here 30? 30. You can draw here 30. Why? Yeah, 30. 30 can be drawn here. Okay, the same 30. So this 30 is parallel to 60, that is 20, and these two are series, 21, and 20 and this 21 are parallel. You will get finally 10 plus 5, 10 plus 5, 5 here, so 15 point. So the total current will be 4.92. But you don't need total current, we need I naught here, I3. So I3 equals this total current. Total current is being divided, okay, divided here and here. Okay, this we no need, 60 parallel 30, we need this. So opposite resistance is 20, the same resistance is 21. So by using I3 equals, since it is in opposite direction, this direction total current is in from right to left, but we need I3 as opposite direction, so that's why minus 4.92 the total current multiplied by the opposite resistance is 20 and divided by the total resistance is 20 plus 21. Is it clear? This is 4. So 4, sorry, this is total is minus 2.4. So we got 4.8 as I1, 4.8 as I1, and I2 just now I explained here 1.6, 1.6 minus 2.4, this one. Finally I naught you will get 4 ampere. Is it clear? Okay. Thevenin's theorem also finished. Thevenin's theorem, maximum power transfer. Oh, so this is the lecture for today. Okay, we finished today source transformation theorem and superposition theorem. Okay, I will explain you in the same video, same audio video. I will explain why, because source transformation theorem is not finished. Finished, but it is not recorded. So I will explain you again. Small problem, first problem I will explain. Why? Because it will be recorded. So this is the first question of source transformation theorem. The current source with parallel resistance can be converted to voltage source by using Ohm's law, and that voltage source will be in series with the same resistance. Okay, we will go for the solution for this. See, see here, this current source can be converted to voltage source. V equals IR, like this. V equals I is 0.6 milli and R is 1 kilo. You will get 0.6 volt in series with the same resistance, you can see here. And here on the left hand side, V equals IR. What is I? 2 milli multiplied by 2.7 kilo. You will get 5.4 volt in series with the same resistance. And 2.3 kilo is as it is, no change. Now you can, in series voltages can be added and the direction is same. So 0.6 volt plus 5.6 volt will be 6 volt. In the same way, all these resistances are in series, can be added, you will get 6 kilo, like this. Now find the current, but the direction of I naught is opposite. So it will be minus I. What is I? V by R. That is 1 milliamps. So I naught will be in minus 1 milliamps. Okay. This is about superposition theorem, first problem. Second problem is this one. You have to find I naught by using source transformation theorem. The voltage source in series with the resistance can be converted to current source in parallel to the same resistance. Okay. First convert this voltage source to current source. I equals V by R. V is 100, R is 20 kilo. Okay, it is 5 milliamps. 5 milliamps and series with the same resistance, 20 kilo. Now 80 is already present here. These two are parallel. You will get 16 kilo. Now this 16 kilo 5 milliamps can be converted into voltage source by using Ohm's law, like this. 5 multiplied by 16 kilo equals 80 volt. This voltage, this current source has been converted to 80 volt and the resistance is 16 kilo. You can see here 18, 16 kilo. And these two are series. And also here we have 3 kilo and 1 kilo. These two are series, can be added. It becomes 4. 4 and this is 16. 16 and 4. Okay, these two can be added again. And added and can be converted into current source, like this. 80 divided by 20 kilo. It is 4 milliamps. Then you will get the circuit like this. 4 milli, 12 milli. But in opposite directions. These can be added. How? 12 milli minus 4 milli. Why? Because since they are opposite direction. And this is less. We are taking minus to this. And these two are parallel. 20 kilo, 60 kilo. You will get 15 kilo. So this current source is 8 12 minus 4 is 8 milli, and these two are parallel, 15 kilo. Is it clear? Here is 5, here is 10. So again you convert this to voltage source. 15 multiplied by 8, you will get 120 volt, like this. All are in series. Okay. By using Ohm's law, you will get I naught equals 4 milliamps. Okay, we finished today. Is it okay? Clear? Thank you.